And so what we have happening in this part is section 8.1. And 8.1 for you is due next week. Not due right now, but I wanted to give you extra time on your chapter 7 so you had a chance to get that done. So 8.1 is looking at linear equations and solving those. And so our objectives in here, this is just not going to give me everything I wanted in there. There we go. Is to determine if the given points lie on both lines in a specific systems of equations. And a systems of equations is two equations that cross each other or don't cross each other and end up being parallel, or they are on top of each other and are identical to what we're doing. So estimate by graphing the coordinates of the intersecting of those systems, and then we can come up with that, and then also using your graphing calculator to solve those systems of linear equations and coming up with what that answer might be for those. So that's our objectives, and that's what we're going to end up looking at. So first off, in 8.1, they ask us if something is a solution of a system. So it says show that 2, 1, there should be a comma in there, is a solution to this system. So I'll let you give you a chance to get that written down. So basically all you need to say is the solution 2.1 to the system if you want to abbreviate it and come up with what your values would be in there. So if it is a solution, it will make the statements, each one of these statements, true. So if it is the solution, both equations will be true. So if I plug it in the first one, and any time in our points, x comes first, y comes second. So it means wherever I have an x, I'm going to plug in a 2. Wherever I have a y, I'm going to plug in a 1. And I'm going to check it to see if it works. We've been checking these for quite some time with our algebra. Plug 2 and 1 into here. So we're going to have 3 times 2 plus 1 should equal 7 if we are doing what we're supposed to be doing with that. Now we got another box. So 3 times 2 is 6. 6 plus 1 does equal 7, so we could say yes, that this is a solution to that system of equations. Now, not always are you going to be given the point that makes the system. We're going to have to find it sometimes, and so that's kind of the goal with this. So if I flip that page over, we're going to show that this one is not a solution to this system of equations. So if I plug in my values, is it going to work? Well, if I plug it into the very first one, y equals a negative x plus 4, my substitution, 4 is going in for x, 0 is going in for x, and 4 is going in for y. So 4 equals a negative 0 plus 4, so 4 equals 4. So this kind of leads us to think, this works. It works for the first one, but does it work for the second one? So plug 4 in for y for the second one. 2 times 0 plus 1, and here's where everything falls apart. 0 times 2 is 0, plus 1 is 0. So 0 plus 1 is 1, and we find out that it does not work there. Basically, what it is showing us is that this point, this 0, 4, is on this equation. It's in this one. If I graph that and I looked at it, I would find the point 0.04 on it. But if I don't do that, it ends up not working out, and so therefore I get my big change that's in there. And so we know that it's not the solution, so we can't have our solution to that one. Okay? Right. They will put solution or no solution, or yes or no, and you would click, in this case you would click no, that it is not a solution. Okay, so it's not a solution for that one. So again, it's just plugging in your point, seeing what takes place, and seeing what happens with that, and getting your systems of equations. Now, what's going to show up on here when you look at your full systems of equations is this part. And when we graph them, this is only one way of solving these. Is it the best way to solve the systems of equations? No, because you got to be so precise with it, and you got to know exactly where stuff crosses at. So what this shows is that we've got a graph of one line. We have a graph of the second line. And so what's showing is their intersection in here. So it's the spot in which the two cross each other. So you're looking at where they end up crossing. This is what's classified as consistent. Consistent has an answer. So there is only one answer to consistent questions. So if it's consistent, we're going to have one solution, and if it fits that category. If you look at the next two lines in here, these two, what's happening with them? Well, if you look at the two, this equation is basically the same as that equation. The only difference is that your constant value, or the value in here that's going to end up giving you your intercept, is going to end up being different. And that's what ends up giving me two parallel lines. So if they're parallel to each other, the two go on indefinitely and never cross each other. So they never, ever see each other. So it's kind of like I-75. Of course, I-75 winds around, but the lanes never cross each other. They get close maybe, but they never cross. But in this case, because they are parallel, they stay an equal distance apart, and there's no solution to those. So that's considered to be inconsistent. So, so to be inconsistent, the lines are parallel. There's a window though. So we end up getting our parallels in here so that we have our inconsistent situation with parallel lines. The last one that we can have within our graphing is where we have identical lines. So what happens here is if I take this bottom equation and I multiply every piece by 2, I'm going to come back with the very top equation, and so they're identical to each other. So they end up being that there's the ordered pairs for every one of these is going to satisfy the next one. So whatever you have for an ordered pair in here is going to make that line end up being on top of each other. So it's considered to be dependent, or every value works to solve the equation. So every value is going to work to solve the equation. So therefore, it's going to end up being the piece that comes together and is going to work for it. I'll call you. So far we're back up and running. I think we got everything up there that's supposed to be with this one. So every value works, and to solve that equation. So you get 3 categories that happen to fit with that one. And so we've got those parts and those pieces that come together. So our process that we're going to do, and I'm going to go into Hawks here if I can switch screens. We'll see how well this thing wants to work today. And we'll go in and take a look in your homework section on how to do these, because it's set up a little differently and how Hawks does that, and so forth. And then it pops things in for you that normally if you were graphing you would have to graph. So to solve the systems with graphing, you need to graph both linear equations in the same set of axes. So that means that we're going to make one Cartesian coordinate system, and we're going to end up putting both lines on it, and we're going to find out whether it crosses. We can also use your graphing calculator to do that. So we can end up seeing what it's going to look like on there. Observe the point of intersection if there is one. So if the slopes of the two lines are different, so slopes have a lot to do with this. So if they're different, then the lines intersect in one and only one point, and the system has a single point of intersection. So we only are going to cross at one. These end up being the ones that are consistent. Okay, so we have the consistent ones that are there that cross. If the lines are distinct and have the same slope, meaning that the lines are going to be parallel, the system has no solution, and that's the inconsistent. So they're not going to end up crossing each other or touching each other. So you got some main definitions there. And finally, the third one that we can possibly have is if the lines are the same, then all points on the line constitute the solution, and there is an infinite number of solutions. And that one is the dependent. So we've got dependent situations with that one. And so those end up being the ones that we have that type of classification with. And then it says check the solution. So in both of the original equations, because you might look at it and think, oh, I've got the intersecting point. I know where they're crossing at, but it doesn't really cross at that location or at that spot. So be careful with those pieces and make sure you double check it so that it does end up working. And with these, use the graphing method. Graph the lines as accurately as you can. And again, within Hawks, it'll graph them for you. So that's why section 4.3, I don't know if you've noticed that, in your homework there is a bonus section, which is 4.3, that goes through the graphing that Hawks does. So that you can do on your own, and it will go in as extra credit points as well. And so you've got that piece. So go back to 4.3 as the extra credit piece to this. So then you can see what Hawks does with graphing. And be sure to check your solution. So use that substitution. Make sure you put it back in place so that you know that you did and ended up getting your question done correctly with those. So now it talks about using your graphing calculator. And so let's go and grab your graphing calculators. And we're going to go through and put this one on there so you can see what it does and how it ends up graphing these things out. So if you guys got your graphing calculators, get those. We're killing some time here at the beginning of class when we were trying to get the system working and figuring out how that part worked on there. Again, your keys at the top on here are your y equals, your window, and your window is what sets up your graph in here and sets it up so that you can see where your lines end up crossing at. And then next to it is zoom. Zoom lets you do exactly what it says. Zoom in, zoom out. So once in a while you need to do that. And it also is where you can standardize your graph at. And then next to it is trace. Trace will let you go across on your calculator and figure out where your two lines cross at. You can also calculate that by doing it a different manner, and we'll talk about that in a minute. And then finally at the end is graph, and that will give you the picture of your graph if you hit that button. Now the keys that are above, the blue keys on my calculator, and they might be orange or they might be a different color on yours, are second function keys. So you go to second, hit that key, and it will take you to that spot. So we're not going to use stats plots because that you would use in statistics, or if you had a bunch of data and you wanted to find out what your graph would look like, we'd use that, but we're not going to use that one. Table set, that one lets us figure out where we want our table to start at on our calculator with that one, or it lets us put in X's. Format, we don't really do much with it. Calculate, above trace, is where we can find that intersection if we hit that key. There's an intersect piece, and we'll do that in a second here. And then at the end, the table. And the table shows you the numbers that the calculator has plotted or put into your calculator to show that graph. My graph was starting at a negative 22 in my table, but if I go second to Windows and get my table set, I can change that back to 0 And so now when I hit table, my table will be more reasonable, and it will be back at the 0 level in there for that. And again, it's kind of hard to see that. Let me get the 2 lights over here. That might make it. Oh, that's what makes the calculator disappear. That's kind of back. Okay, so let's work the one out that's up here. So first off, if you have it not set equal to y, we need to get it set equal to y. So if I have 2x plus y equals 8, I need to get y all alone, so that means I need minus 2x from both sides, and find y is equal to negative 2x plus 8. And so that's what we do to solve that. So they've already went through and solved it here. Then you do the same thing with the second one. X minus y equals 1 minus x. But that leaves me with a negative y equals a negative x plus 1. Change all of my signs because I need to divide by negative 1 because y is not alone. And that will give me y is equal to x minus 1. And that's where they get this piece at. So that's my 2 pieces. So if I go to, we good there with that part? Solving for y's and getting stuff by itself? Okay. Then if we go back to our y equals, and if you hit your clear button, let's see if I can find the spot there that shows, I don't know. I can't get the calculator ever to show right up here. If I clear it, then I can put in my 2 pieces. So I'm going to put in a negative 2, x is next to alpha, plus 8. And then if I go down, I'm going to put x minus 1. And now if I hit graph, it will show me both graphs coming in. So do you guys get that on your calculators? Because sometimes with your calculator there might be things that are on that don't let you see that. Did we all get that? Okay. Because if you have up above here, when I go back to my y equals, if any of these plot pieces are on, it won't let you graph. If your window's not set right, it will not let you graph. So there's some things that you need to set in there. So now if I go back to graph, where do these 2 cross at? Well, if I look over here, I can almost count with this. 1, 2, 3. Probably x is 3. And y is 1, 2, 3 also, maybe, within that. So I can kind of get an idea. If you had it on paper, you would probably see it a little bit easier than on your calculator. But if we go up to calculate, up above the trace button, if we go second, calculate, and under calculate, you've got all kinds of things you can do with your graph. But if you go down here to number 5, and 5 is intersect, and if I keep hitting enter, right now it's looking at the first graph, and it's giving me a point. So it's giving me basically its y-intercept. And then if I hit enter again, it's going to give me the second curve's y-intersect. Hit it a 3rd time, it gives me a guess. Hit it a 4th time, and it will give me my intersection. And so at the very bottom here, x was equal to 3 and y was equal to 2. So that shows me where it intersects. Pardon? To do this calculation, the question was, which button do you hit? Well, you're going to go second. You're going to hit your trace button. So it's second, the trace button to get you to calculate. Okay, are you there? Okay, so second to trace, which gets you to calculate. Then under calculate, we go down to number 5. And 5 is intersect, so I can either down arrow to 5 or just hit 5 and it will take me to intersect. Okay? So then if I hit enter 4 times, it's going to show me where the intersection happens to be. So it's intersecting at 3, 2. And so that would be the spot where it crosses at, of 3, 2. Okay? Does that make sense? Okay. And this just goes on, and I will post this it will go in the notes, but this just goes on and it shows them putting in that values into your calculator. They have a tendency to do stuff a little bit differently than what we have did it before, so or what I just did it. They kind of don't always break through and end up just showing you the enter in there. So how we did that was we first plotted our line, put it into our calculator, then we hit graph to see what it looked like. Then we went second to trace, down to 5 to intersect. Then we hit enter 4 times, once, twice, 3 times, sorry, it's 3, not 4. So hit it 3 times, and then it will show you at the very bottom what your intersections happen to be that are at the bottom part of that. Okay, so now let's go and I'm hoping I don't screw it up again here, but I want to take you to the actual Hawks stuff that you will have, and the reason I wanted to do that is that in here, in your actual practice stuff, it shows it a little bit differently, and I didn't want to leave you without showing you within the practice piece. So I'm going to go into practice. You guys don't need to go there. We can take a look at what comes up here on the screen. And in this one, it is asking me to determine what my answer is to this system of equations. Well, I know I need to find out where the 2 lines cross each other at. So as they cross each other, that is the location, okay? So basically all I need to type in for my answer into this part is just simply that location. So where is that? If we looked at this graph, where is that spot? So that spot happens to be at a 2, -2. We all agree? So then if you go down here and type in 2, and then put a -2, we should be good to go. And we can get our answer in there and submit it and move on to the next equation. This one here is determine whether this is the right solution. So I think we're good there, aren't we? All we got to do is plug that in, see if it works for both equations, and come up with our answer. So we're going to skip this one and move on because I just want to show you how the different ones show up. Now this one is going through and asking you to take this problem and solve all of these and get it solved for y. Now we did that before, so what would you get if we solved this one for y? So take your paper out and solve it for y, and let's see what we get. So we can show, so I can show you over here what it actually does when it graphs. So I'm going to move my -6x over. So that's going to end up giving me 2y is equal to 6x plus 26. Divide by 2 every piece. So I find out y is equal to 3x plus 13. Y'all agree? Is that what you ended up with? So you type that in here. So 3x, don't type the x because they already have it in there, plus 13. And notice what it did in your graph. It went through and it graphed that graph in there for you, okay? So then do the same thing with the next one. So if I go through and take 5x plus 5y equals 25, move my 5x over, leaves me with 5y minus 5x plus 25, divide by 5, and I find y is equal to a negative x plus 5. Now I can't just put negative there. You're going to have to put a -1 in there because it won't accept it. So you can put a -1, and then we're going to put 5. And so as soon as I do that, what happens? It graphs the second line. Okay? So you got blue lines and pink lines. So now the next piece is how many solutions? Does it have one solution, no solution, or an infinite? Well, it's got one solution because it crossed, and then you just calculate where it crossed. So my point at where it calculates to cross is a -2. It accepts my question here. -2. And what's the other point? What's y going to be? Y is going to be kind of hard to count out there. But you can, again, take your, when you're on Hawks, you can count it from here. 1, 2, 3, 4, 5, 6, 7, it looks like. So put in a 7 and then hit it and submit it. So you're going to have the Hawks program itself is going to do a lot of the graphing for you. Okay, does that make sense? Hopefully. Okay. And then this one, it says determine, and again, you guys know how to do that, so we're going to skip it. And then we get another one to graph. And it says the sum of two numbers is 40, and their difference is a -30. So they go through and write this whole thing out. Let x be the number and y be the other number to the corresponding model. So if you read it, the sum of two numbers is 40, so x plus y is 40, and their difference is a -30, so if I subtract the two, that's where the system comes from, okay? And we're going to look at some story problems here in a little bit, but I just wanted to show you in here. So you do the same thing again. So we solve for y. So you got to get good at solving for y with these and make sure that you get your pieces in there so that they all come together. And then what it will do is, again, it will plot it for you. So if I move my x over, it's going to be a -1 for x, and it's going to stay as a +40. And then in the bottom one, if I move x over, it's going to be a -x or -1x. And the x value is going to be a -30, or the constant term is going to be a -30. And so as soon as I do that, hopefully it plotted it in there. Did it plot it? Oh, it plotted it down below. So notice this line is here. This line is way down there. So what does it tell me about this thing? Does it have a solution? It's got one solution? Or does it have no solutions? So what do you think? It's going to have no solutions, because if we plotted it correctly, we're going to end up getting, whoops, nope, I forgot to change my signs in here. So I'm wrong. When I moved the x over, it became negative, but with my y, there was still a negative in there. So that really needs to be a positive. So let me delete that piece. And my 30 would also have changed. So I need to backspace and delete that. Now I get a cross. So think these things through, and I forgot to change my signs in it. So it does have a solution. So its solution is one solution. And it ends up crossing at, what's our value in here? Is it 10? Or is it, it's between the 0 and 10, so it must be a 5. And then where's it at up here? Well, it's up at 35. And so we're going to submit my answer. And now I did it right. If I had submitted it, it would tell me, wait a minute, you did something wrong. Okay? So again, it's going to give me a similar one, and I think you got the idea, correct? I hope so. So let's skip this one. And it's going to give you another one. And again, they go through and give you the words up here that represent your system. It gets you practicing that, because in 8.2, we get into some other story problems, and we got to set some stuff up there in those. So we're going to skip that one too, and skip this one because it gets into giving you a lot of patterns with that. Okay? Now, this one's a little different. This one has a bunch of fractions in it. So I'm going to write this down, and we're going to take a look at it, because I think we need to take a review of what we're going to do with fractions. This is kind of going back to chapter 7 when we had that stuff. So let me put this on paper. And I will flip screens here, hopefully, and not have an issue. And we'll go back and see if we can get this thing at least solved in here. And so now if I put this in here, we can go back through and take that and solve it. Since if we learned our skills from chapter 7, we can get rid of these fractions. So we get rid of them by multiplying everybody by 6. So 3 goes into 6 twice. 2 times 5 is 10x. 6 times a negative 4 is a negative 24y. And 2 goes into 6. 3. Continue with this piece in here, solving this. We get this piece, and then 3 times 2 is 6. Get 336. And then the bottom one, we will do the same thing and multiply everybody by 3 and get 27x minus 2y equals 3 times 76. 3 times 6 is 18. 3 times 7 is 21, plus 1 is 22. And now I can solve it a whole lot easier. Minus 10 from each side. And then in the bottom, and then to finish this, I'm going to divide everybody by negative 24. And I find y is equal to, canceling these out, and the negative is going to go away. I get 5x over 12. And then over here, the same thing. It's going to be a negative. And 24, and that, 336. Whoops. Equals 14. So I can get it broken down to what I needed it to be. And then if I do the second one, I can end up breaking it apart and moving the 27x over. Divide by negative 2. And I end up finding out that y is equal to a negative 27, or positive 27 over 2. And 2 will go into their negative 114. So anyway, that's our pieces. But that's what you'd have to do. And let me see if I can go back to my switch screens here and get back to my Hawks, hopefully. And so there I'm back to Hawks. Okay, yes. It's going to be in 2 pieces. Okay. Yeah. So I would put my pieces in here, but with this problem, now I'm not able to get to see my whole problem. I don't know. What a day. Technology in its finest is what we got going on, and now I got this weird something going on. Oh, that's to save that, so I got to hit OK. But anyway, you would have to solve it, and then if you plugged your stuff in, it's a good thing Hawks is graphing this one, because it would show it up that way. So we're going to skip that one and go on. I wanted to make sure I had the fraction. Here's a different one with fractions. They probably put in about 3 of those, and so then we end up with this one too. Okay, so you got the idea with fractions, you think? Okay. Again, it's going back to chapter 7 and seeing what you can do with that. So my other screen just decided to go away again too. Oh, maybe not. We're going to leave it like that. So I don't know. So anyway, so that is what we end up doing with this section. Now they did give you some story problems, but the ones they gave you in your packet, and I've got these for you, or in your section are already written out for you. So again, this is just taking a look at what we've got with those pieces. So we will not write these out because, again, you don't have that part in there. If this feels thick, it's because it works for, I think, all of chapter 8. Oh, did I give you an extra? Yeah. This is all for chapter 8, so it's got our story problems for the next few sections in there. There you go. Okay. All right. So in 8.1, they are all worked out for you, and so that ends up being the key thing to that part. So so that's 8.1. So let's take a break. Yep, move around. Be back at 10 after should work, and we will continue on. Again, they don't have them broken out without having the equations for you on these story problems, but again, they're here, and in the notes I will write those out so that we have those in place. 8.2, this is also not due till Wednesday next time. But again, that day in between, we can't afford to lose it because later on we might need some extra time. So from now on, all of your tests will be just, they're all going to end up falling on Mondays, but stuff will be done when it gets done. I don't know. I just give up on this. But so 8.2, we have, actually there's 4 ways of working with systems of equations. One we just did, which was graphing, and graphing is probably the least accurate of all of them. But in 8.2, we're going to solve systems of equations using substitution. And substitution, just like the word means, we're going to substitute a value in for a variable that we solve with one of the equations. And so this part here is just basically solving systems of linear equations using the method of substitution is what we're going to do in that section. So how do we do this? Our methods are going to be solve one of the equations for one of the variables. Usually you will have within this section a variable that's real easy to solve for. Your choice is yours. We don't choose them, and you don't say, oh, you always got to solve for X, or you always got to solve for Y, or you always got to solve for Z. You just end up solving for whichever one you pick. Substitute the results of the expression as the other equation. Very important. Don't put it back into itself. So use the other equation when you do that. Solve the new equation, if possible, and then substitute it back into the original equation to solve the other value. And then finally, check that original equation to see if it ends up working. So we're going to end up going through and taking a look at one of these equations right here. So if we look at this one, for instance, what letter do you want to solve for? Well, the first equation's already solved for us. It's solved for Y, so that's a good sign. So we got Y by itself. So what this means is this piece gets to replace that Y. So I'm going to be left with 1/6x plus 5/6x plus 2 is going to equal 8. So since our x's are in 6th, we can do what with those? What do you guys want to do with those? Just add them together, right? 1/6 plus 5/6 is 6/6x or 1x. Then subtract 2, and we find out x is equal to 6. So if x equals 6, then we need to solve for y. So I'm going to go back up here to the original statement and put 6 in where x is at. So 5/6 times 6 plus 2. These 6's will cancel because that's over 1. So y is equal to 5 plus 2, or y is equal to 7. So we get 7 for our answer. And finally, check it. So if I put 7 back in here, is equal to 5/6 times 6 plus 2. We just kind of did that one. So 7 is equal to 5 plus 2, or 7 equals 7. Plug them both into the other one. 1/6 times 6 plus 7 should equal 8. And these 6's cancel, so 1 plus 7 does equal 8. So 8 equals 8. So we know it worked. So we know our system is working with that one. Okay. Another one. Let you get that one written down. Example 2. Yes. In Hawks, it will say, here's your system of equations. What is your answer? So in this last one that we just did, it would say, what is your solution to this? And our solution happened to be 6 and 7. So you would put in a 6 for x and a 7 for y, and you'd be done. Okay? Yeah. So in this one, what do you think we should solve for? Y? Yeah, exactly. So the first one, we got 3x plus y equals 1, and we can end up getting y all by itself pretty easily. So 3x plus y equals 1 minus 3x, and we find out y is equal to a negative 3x plus 1. Once I do that, then I have my equation that I can take, and I can take this piece and plug it in where y is at in my second equation. Don't plug it back into itself because it won't work. So 6x plus 2 times a negative 3x plus 1 is equal to 3. So if I stick it in there, I'm good to go. Okay? So I get 6x. 2 times a negative 3 is a negative 6x. 2 times 1 is 2 equals 3. 6x minus 6x, what happens? They cancel each other out. So I end up with 2 is equal to 3. When this happens, this is kind of a special situation. So if the variables disappear, so if the variables disappear and the numbers are not equal, the equation has no solution or is inconsistent. Am I off the screen? Sorry. The solution is inconsistent. Okay? Inconsistent meaning there's no answers to it. Okay? So in Hawks, it will probably say one solution, no solutions, or many solutions. So then you will select whatever box there is with those, and then in this case we would have selected no solution, and we would be done with our problem. Do I need to go and do anything further with it? No, I can't. I can't get any numbers because there is no numbers. Both of these lines, if you graph them, they would be parallel to each other, because notice, if I take the top line and multiply everything in it by 2, then this piece will match, but my slopes would be different, and that's the part that makes it become inconsistent, and so it doesn't work. Okay? All right. So we go back to the next equation. Which letter on this one would you want to solve for? So we could look at the second equation here and say, oh, I'll just take that one and solve it for x. Would that be what we want to do? No. So if you're looking at any of these and you got a single variable, no numbers in front of it, that's the one that you want to take a look at, and you want to go back and solve for that one. So in this one, I'm going to solve for x. So if I add 2y to both sides, I get x equals 2y plus 1. This time, it replaces x, not y. So now I can replace x with it. and solve it for y. 3 times 2y is 6y. 3 times 1 is 3. Minus 6y equals 3. Here, both variables disappear again, but I have a true statement. So if it's true and all the variables disappear, so if all variables disappear and the numbers are equal, you have many solutions. Or it's considered to be dependent. So if everything disappears in there and we end up with our parts to it, we have that case of many solutions. So that's what we get with this one. Okay, so that's our pieces. Questions with that part? It's easier than doing the graphing piece and going from there. So that's that piece. They do give you some decimals, and you get some decimal pieces in there. So would it make a difference if I solve for x or if I solve for y up here? Both are by themselves, so I get single values. And so then what ends up happening? So I can solve for either one. So if I do that, let's just solve for x in the top one. Plug this back in. If you did not like decimals in here, some people don't like working with decimals and would prefer not to have them, you can take this whole piece and multiply it by 10 because everything's in the tenths place and get 2x plus 3y equals 9. Then do your substitution. It just might make your math a little bit easier and you have fewer spots to make mistakes in. So remove decimals if possible. So you can remove decimals in there if you need to. So finishing it, negative 2y plus 10 plus 3y equals 9. Negative 2y and 3y is y minus 10. So y is a negative 1. Go back over here, plug a negative 1 in for y. So I get 1 plus 5. So x must equal 6. And if it's going to equal 6, we need to double check it. Since I just worked with this one, let's try it in that bottom one and see if it works. So 0.2 times 6 plus 0.3 times a negative 1 should equal 0.9. So 6 times 0.2 is 1.2. Negative 1 times that is a negative 0.3. And 1.2 minus 0.3 does end up equaling 9 or 0.9 or 9/10. So it does work. So I don't know. What do you think? Make sense to these things and what we do need to do with them? Hopefully. There are some other ones that we have in here that are practice ones. I don't know. Yeah. The question was, if you don't multiply this by 10 to get rid of your decimals, will it still work the same? Yes, it will work the same. It's just that you've got a lot more to keep track of. That's the only thing. Because you would still plug in your negative 1 or your negative y plus 5 in here, and it would still end up working out correctly. But you just got to keep your decimals in place. The others that are in here, these are practice ones, and I'll go through and work those out within the notes in here for what we've got with those. Then if you turn to your story problems that I handed out to you, there's a couple in here that we need to take a look at. And the first one is all set up for you. And it's got 10 gallons of salt solution, consists of 30% salt It is the result of mixing 35% solution with a 25% solution. We are going to do these in section 8.4, so it's not like they go away. 8.4, they will not be set up for you, and we'll have to set them up, and we can use charts for that. It says the solution was 25%. How many gallons of each solution were used? Let X equal the number of gallons for the 35% and Y the number of gallons for the 25%. The corresponding systems is this. And then what you do is go through and solve it just like we just got done doing with that. And so we could solve for X or Y up here with this one, substitute it back in, and we'd end up coming up with our solution. So let's finish it. So we got, if I solve for X in here, so X is going to equal a negative 10 plus 10, or negative Y plus 10. We'll leave it as decimals this time instead of replacing it and putting it in there. So if I replace X with that, I'm going to have 0.35 times a negative Y plus 10 plus 0.25Y. 10 times 0.3 is going to be plain old 3. So 0.35 times a negative Y. 0.3 times 10 is going to give me plus 3.5, and plus 0.25y is equal to 3. Put these two together, I'm left with a negative 0.1y plus 3.5 equals 3. Subtract 3.5. So I find out that y, or negative 0.1y is equal to negative 0.5. Divide by 0.1, negative. So y is going to equal 5. So if I have 5 gallons for the 0.25 solution, how many do I need of the other? Plug it back in, put 5 back in here, subtract it from 10, and we'll find out that X is also equal to 5. So I would need 5 gallons of each type to work my problem through. So once you get that system, then you can plug your stuff in and come up with what your solutions happen to be. Okay or not okay? And then the last one is a student bought a calculator and a textbook for a course in algebra. He told his friend that the total cost was $145 without tax, and that the calculator cost $25 more than thrice. What's thrice mean? I don't see thrice. You see twice. You see all those other ones. So thrice must mean 3 times. The cost of the textbook. What was the cost of each item? So there's 2 systems in here. There's 2 pieces to this. What did he purchase? A calculator, and so we're going to make the calculator equal to C, and he also bought a textbook, and we're going to make that equal to T. So what do we know about them? He told his friend that the total cost was $145. So what does that mean? C plus T equals 145. And then if we read on, we got to get the second equation. So that's the first one. So the second one, it says the calculator costs $25 more than thrice the cost of the textbook. So that, what does that tell me? So the calculator is 3 times the textbook. We got that part. So what happens to this 25? Does it get added to the calculator cost, or does it get added to the textbook cost? The calculator costs 25 more than thrice the cost of the textbook. So it's got to be added to the 3 times the textbook cost to come up with what our solution would be. And so then we've already got one solved for C. So I can just plug that back in and solve for T. So 3T plus 25 plus T equals 145. So 4T minus 25 is going to equal 120. divide by 4. I find out the textbook costs $30. So what would be the cost of the calculator? Plug it back into this piece. 3 times 30 is 90. 90 plus 25. So the calculator cost $105. Now, with your story problems, be careful in making sure you put the right number in the right spot. Like up here, when we use X's and Y's for this solution, you need to pay attention to which one was which. The 35 was associated with the X, and the Y was associated with the 25. So when I plug that answer into Hawks, I need to put them in the right spot. Same as down here. It will have calculator and textbook. You need to make sure you put the calculator cost where the calculator goes and the textbook cost where the textbook goes. So be careful when you read these and that you end up getting them in the right locations for where they need to be. Okay? And then I just got the answers to the practice problems that are back here. And those I will provide, so people will have those to look at if you need to. Okay? Again, one method. This is just one solution or one way of solving systems. So we've got 2 down today. One is graphing and one is the substitution method.